Hello. So now we solve the problem. So in order to solve any double integral, it's better to have a good understanding of the domain of the integration. So here, according to the problem, D is a region which is bounded by the coordinate axes as well as the curve x to the power of 3 plus y to the power of 3 equals to 1. Okay, so let us try to sketch a graph of this curve, or at least visualize what does it look like. Okay, so for this one, I set up a coordinate system. This is x-axis, and then this is my y-axis. And then I realized that the point with coordinates 1 and 0, as well as the point with coordinates 0 and 1, both of them actually satisfy the equation of this curve. Yes, if you replace x with 1 and y with 0, this equality holds. The same is true for the other way around. So this means that these 2 points definitely lie on this curve, and this is easy to highlight them. So for example, let us consider this point. For example, assume that here the coordinate is 1, and then here is also 1. Of course, here you know that this is a polynomial of degree 3, so it is continuous everywhere, and it is supposed to pass through these points. Okay? So the real shape of this curve is not that important for our calculations here. So I can imagine that the curve is like that, or I don't know, the curve is like that, or the curve is like that. But of course, if you want to have a better understanding of the curve, that is also very simple to do. For example, you know that if you want to know some information, you get some information about the curve, how it looks like, you use the derivative. But of course, here my function is an implicit function, so I will do the implicit differentiation. So I differentiate everything with respect to x. This becomes 3x squared. So if you don't mind, let me start from here. So this becomes 3x squared, and then I will have 3y squared, but y prime on the right hand side I will get 0. So I want to make y prime alone. So this becomes 3y squared, y prime is equal to minus 3x squared. And assuming that y is not equal to 0, I can divide everything by 3y squared. Simplifying 3's, I will get x squared over y squared. Okay, this is on the condition that y is not equal to 0. So if y is not equal to 0, this quantity, because of even powers 2, is a non-negative quantity, but when you multiply it by a negative sign, it becomes negative. So it means the derivative of function y is always negative, so the function is always decreasing. And it is also supposed to pass through these points. On the other hand, you see that if I put the coordinates of this point, say 0 and 1, in this derivative, the numerator becomes 0, the denominator becomes 1, so the derivative becomes 0. So what does it mean? It means that at this point I have a horizontal tangent line to the graph. So let me just draw that line. So you know that this is going to be tangent to your graph. Okay, but you know that the graph cannot act like that, or it cannot act like this, because we just learned that the function is always decreasing. So this is not a local maximum or minimum, it is a terrace point. So if you want to sketch the graph, it looks like this around that point, yes? Something like that. Okay, but then if I put the coordinates of that point, which is 1 and 0, here, instead of x, I put 1, instead of y, I put 0, then you see that y prime is not defined, or it is infinity. So this means that I have a vertical tangent line here at this point. Yes, and everything is now become clear, because you are supposed to have a smooth curve starting from here in this form, and it is supposed to end here in this form. So yeah, then I hope that you agree with me that we have actually a good understanding of our curve now. So if I ask you where this D is, it should be limited with the coordinate axis and this curve. So this is actually the region that the problem is talking about. And we are supposed to integrate over here. Okay, so the way that they have written the integral, they have given the priority to integration over x first. And sometimes you know that we have to change the order of integration, but in this case it doesn't matter at all, because the function that you have is symmetric with respect to a change in x and y. If I change x to y and y to x everywhere, nothing changes. So it doesn't matter here. So if we can solve this one with respect to x, that is exactly the same level of difficulty if I want to change the order of integration. So I will keep it like that. Okay, so my goal is to integrate this one first, the function with respect to x. Okay, so for simplicity of writing, so let me call this integral. Okay, so let me actually try to write this once more. So the integral that I have, I want to do it in this form then. So integral of x squared, y squared, the second root of 1 minus x cubed minus y cubed, and then I have dx, and then I close it, and then dy. Okay? By this way of writing, I am choosing y to be a free variable. So if you come back to the domain, you see that in this domain, the lowest value for y is 0, and it goes up to at most this point, which is 1. So these are the limits for the y variable, from 0 to 1. But the only thing that you have to be careful, don't say that the x variable also goes from 0 to y. No, because for any choice of y between 0 and 1, you need to know how x varies. Yes, what do I mean by that? For example, I have infinitely many choices for y. Let me choose one of them. For example, let me choose this one to be my y. And then, if I am standing at this particular y, I want to know how x changes. Of course, in that case, it is clear that x changes from here up to there. So for that particular value of y, this is my x. Okay? If this is your y, and if this is your x, if I ask you what is the coordinate of this point, you immediately tell me that this point has coordinates x and y. On the other hand, you see that this point lies on this yellow curve, and this is the equation of the yellow curve. So this means that these coordinates should satisfy this equation. Okay? Okay, so this means that x to the power of 3 plus y to the power of 3 is 1. I assume that y is given. This is the given y value. Then I calculate x value. So x to the power of 3 becomes 1 minus y to the power of 3. And then x becomes the cubic root of 1 minus y cubed. So this means that the lower value for x for any choice of y is 0, but the highest value that x can attain for that particular value of y is this quantity. So this means that if I want to fill up these limits, I go from 0 up to the cubic root. Oh, sorry, I forgot to put the cubic root here. Up to the cubic root of 1 minus y cubed. And then, for simplicity of writing, I will call this integral I, but of course, because it depends on y, it's better to call it I of y. Okay, and then I concentrate for a while to calculate Iy. Definitely, you shouldn't expect to get a number. You will get a function of y. Okay, so now let me start calculating Iy. So to calculate Iy, first of all, you need to understand x is your integration variable. So as far as this integral is concerned, y squared is a multiplicative constant. So I can pull it out from my integral. So this becomes y squared integral from 0 to the cubic root of 1 minus y to the power of 3, and then I have x squared square root of, and if you don't mind, let me write minus y cubed next to 1 and y cubed separately. It becomes clear why. The reason that I did that, because as far as this integral is again concerned, this is just a constant, so you can call it a. Then your integrand becomes x squared, the square root of some number, constant number a, minus x cubed. So you see that you want to integrate this function, but if you have already studied the previous lessons on integration theory, you know how to do that immediately. Why? Because if you see this function is of third degree, if I differentiate it, it becomes of second degree. Whenever this happens, that the derivative of one part of the integrand up to a scaling factor is multiplied, it appears as a factor, then the method of substitution is the best way to think about. Okay? So I will do the same thing. So what I do, I would say that let u, for example, be equal to the square root of 1 minus y cubed minus x cubed. For simplicity, I will square both sides and then differentiate. So I square both sides, I will get this, and then I differentiate. The left hand side becomes 2u du. The right hand side, the derivative of 1 is 0. The derivative of y is also 0 because my differentiation is with respect to x. The other term becomes minus 3x squared dx. But because I have x squared times dx as the combination in my integrand, this motivates me to make this alone. What I do then, I divide everything by minus 3. So I get minus 2 over 3 u du, and on the right hand side I will have x squared dx. So let me keep this for the future. Okay. Now, the next thing that I have to consider are the new lower and upper bounds, because these are upper and lower bounds for x, but now my variable is u. And that's also very easy. So for the lower one, x is equal to 0. So I replace x with 0. Okay, so if x is equal to 0, what happens to the u? U becomes the square root of, a square root of 1 minus y cubed. But be careful, this is the lower limit because it is corresponding to the lower limit for x. And if x is equal to the cubic root of 1 minus y cubed, again what I do, I go to u, I take x away and replace it with that expression. This power of 3 will cancel this cubic root. So then what happens? U becomes square root of 1 minus y cubed minus again 1 minus y cubed, which is simply 0. Okay, so then what happens? This means that y is equal to, here I have y squared, so let me write it, and then x squared dx is this expression, but minus 2 over 3 is a constant, so I can pull it out and put it here. So this is minus 2 over 3, and then integral. The lower limit is 0 here, but now the new lower limit is this expression. So this becomes the square root of 1 minus y cubed. The upper limit here, x is this expression, it gave rise to actually 0. So the upper limit here is 0. Okay, now instead of x squared dx, I was supposed to put this part because I already took care of that part, and then this one itself is u. So I have 1 u du coming from this part, and then I have an extra u there, yes, coming from this expression itself. Okay, if you want to, it's not of course mandatory, but I can get rid of this minus sign, but the price is to actually flip these two limits, and then u times u is just u squared. Okay, so what I do, I would say 2 over 3 y squared, and then this one becomes u squared, and the primitive function is 1 over 3 u cubed. So if you don't mind, let me just multiply this 1 over 3 here. So this is 2 over 9 instead. And then I have a u to the power of 3 goes from 0 up to square root of 1 minus y cubed. And then this is simple, so this becomes 2 over 9 y squared, and then I have the second root of 1 minus y cubed to the power of 3. And of course, when I put 0 instead of u, everything cancels out. So I was able to find iy finally. Yes? So iy is actually 2 over 9 y squared, the second root of 1 minus y cubed, but to power 3. So that is the calculation of iy, and as you saw, it depends on my y variable. Okay, so now what we are supposed to do, we have to go back into the original integral. We already calculated this part, so I have to replace it with this expression, and then I have a new integral to do on y variable from 0 to 1. Okay, so the question mark is equal to now, so 2 over 9 is a constant, and then I have integral from 0 to 1 y squared. I have square root of 1 minus y cubed to the power of 3 and dy. So if I want to make it a little bit smaller so that you can see this is happening. So what I did, I replaced that with this expression. I put 2 over 9 out, and this is why I get that expression. Okay, but again the trick is the same. You see that? Because you see I have 1 minus y cubed. Its derivative up to scaling factor also appears here. So this motivates me again to introduce a new variable, say t equals to square root of 1 minus y cubed. Again, for simplicity, I squared them before differentiating them. This is also, by the way, a good technique to learn. And then I differentiate both sides, so it becomes 2t dt. The other side becomes minus 3y squared dy. But again, what combination I need is y squared y, so this will motivate me to divide everything by minus 3. Okay, so let me also keep that. And again, I have to take care of my limits. So x is 0, the lower limit. T becomes what? If I instead of y, if instead of, sorry, that is not x, that is y, because this integration is over y. So then t becomes 1. And then if y is 1, t becomes 0. Okay, now everything is ready, so let us calculate. So the question mark becomes 2 over 9 integral. Instead of from 0 to 1, I have to go from 1 to 0. Yes, because when y is 0, t is 1. Okay, and then instead of y squared dy, I put this expression, but minus 2 over 3 is a constant, so I pull it out and put it here. So it is minus 2 over 3. But now, instead of y squared dy, I have t dt inside. But if you see, this is my t. I have a third power of t again, so I have another t to the power of 3. And again, the same story. So if you want to, I can take this minus sign away and flip them. And then, so it becomes 4 over 27. I just multiplied the constants, and then integral from 0 to 1, t to the power of 4 dt. But then it becomes 4 over 27, t to the power of 4 becomes 1 over 5, t to the power of 5. But then integral goes from 0 to 1. Okay, so I replace t with 1, becomes 1, replace t with 0, becomes 0, subtract them, it becomes 1, and then multiply these constants. If I multiply this constant, 4 times 1 is 4, and then 5 times 25 is 135. And that is the answer to this double integral. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.